We're good to go? All right. Good morning, everybody. Sorry for the small delay. Let me try and keep an eye on time. We're planned until 10, Damien? Okay, yeah, that'll be fine. So, what I wanted to do is to do a tutorial on implementing EasyBlocks. And I opted for not creating slides, but actually writing the documentation for it. So it will be more useful later. So this is what we ended up with. I wrote this last week, and Damien took a close look at it, gave it a good overview or review, and I tried to fix his remarks last night actually, so everything should be there. So I'm just going to run through this. What I want to try and do is to basically follow my own documentation and put together a first draft of an EasyBlock for TensorFlow. So we have support for TensorFlow already in EasyBuild, and maybe I should show that as well. So we have an easy config file. In the last release, it's a little bit bigger. Whoops. So in the last release, we do have an easy config file for TensorFlow already. But what we do is we took the lazy escape and we're installing the binary wheel that they provide. So this is a binary installation basically of TensorFlow, which is not the best option. What we want to do is to do an installation from source and really target it to the system we are installing it for, like we usually do with EasyBuild. So that's the idea. If you go back to the documentation, the TensorFlow documentation, so this is where they explain you how to install it from source. Well, or how to install it, and part of it's how to install it from source. They have a couple of options, so we're doing not Windows. They have a TensorFlow CMake build. I'm not even gonna try the CMake one. I had, yeah, no, it's not a beautiful program at all. Also, for the purposes of this tutorial, it's not a good fit because I can probably get away with an easy config file and I wanna look into an easy block. So what I'm gonna do is the standard installation with Bazel, which is the build tool from Google. It's a shame Guillermo isn't here because he has experience with this and it's a mess as well. Is he here? Ah, there he is. Okay. So for the easy block, I'm just gonna assume Bazel is already there. We have an easy config for it on Cray, and I took a look at it. It should be pretty easy to get it to work on standard Linux as well. So that's not good. That's not going to be a big issue. So for now, I'm just gonna assume we can use that as a build dependency. I'm not gonna do CUDA for now, so let's just do the generic x86 install. So let's try and find the route. So this is already a mess. It's taken me forever to figure out what I actually have to do. The first step is running the configure script. They have a configure script, which is something we're familiar with. And they give an example, and it's pretty clear this is not what we want to do. This is an interactive configure script, so it's going to be a mess. We can never do this in an easy config file. So we'll have to write an easy block for it. So that's good. And let's just get started with this and show you how I would put together the easy block. So just to get started with, so an easy block, I guess most of you know what it actually is. It's kind of like a Python script that integrates with the EasyBuild framework. But you have to follow a couple of rules so that EasyBuild can actually use the script and leverage it when it has to. EasyBuild will figure out which easy block it has to use for a particular software package, either based on the easy block, easy config parameter that's in the easy config file, or if there's no such parameter, it will figure out the easy block based on the software name. So it will go hunting for a software specific easy block. So there's a difference between generic and software specific easy block. So configure make, for example, is a generic easy block. You can use it over and over again to use to build different software packages. There's others like CMake, make, and so on. And here's a link to all of the generic EasyBlocks that we have today in EasyBuild. So this is generated documentation. It's always up to date for the release, the latest release. For TensorFlow specifically, we're going to have a software-specific EasyBlock, so it's going to be something that only works for TensorFlow. All right. And then the question, do we really need an EasyBlock, or can we get away with just an easy config file? We kind of already answered it. The configure is an interactive script, so we're not going to get away with just an easy config file. We don't have the control that we need there to be able to answer the questions that the configure script is asking us. So sometimes you can get away with just an easy config file and using especially these, the config build install opt or the pre-install opt, so you can modify the build command or the configure command or the install command. Usually you can go a long way with that. Or if it's a binary install, you have this binary EasyBlock that gives you the install command, extra parameter, and so on. But we already know this is not going to be good enough. Sometimes in easy config files you can get away with using the available parameters, but it gets really complex and long. And you can even put if statements if you want to in easy config files because it's executed just like Python code. But that's usually something we try to stay away from. So if it's getting too complex, it's a good idea to look into EasyBlocks and basically implement it properly in code, where you can also check things like which toolchain is being used and you can act on it. Maybe use different configure options based on the toolchain being used. Add the configure flags based on the dependencies that are available, stuff like this. So a couple of reasons to use an EasyBlock would be there are some easy config parameters that have to be set right for the toolchain that you're using, and which makes it hard to do try toolchain on the easy config file because you have to go in anyway and change it. Yeah, so stuff specific to the toolchain, interactive commands, which is exactly what we're hitting here now. So that's basically the only way you can handle those is via an EasyBlock. And if you just have the feeling you're hacking around, and some people here are very good at hacking around in easy config files. I'm not looking at anyone in particular for this. Sometimes you just take it a step too far and it's better to fall back. And the recent example of that is the FFTW easy config files, where we also in the latest release we actually have now an FFTW easy block, and we threw away a whole bunch of stuff from the FFTW easy config files because it's all being handled in the easy block now. So they are just basically the only thing you would change now in FFTW easy config file is the version next time, or maybe the toolchain, but that's it. You wouldn't change anything else anymore. Everything else is done by the easy block. So an important aspect of EasyBlocks is the naming scheme. So EasyBuild will look for EasyBlocks based on the name, both of the Python module and the Python class inside the module. So you have to get it right, otherwise it just won't work. EasyBuild will not pick it up, or will complain that it can't find the EasyBlock it's expecting to find. So there's two aspects: the class name, and I'll come back to that in a bit when I actually start my TensorFlow EasyBlock. So the Python class name has to be exactly right. For software-specific EasyBlocks, you will always have this EB underscore prefix, which is kind of an escaping mechanism. If you have a fancy software name like Open Speed Shop, is actually Open Pipe Speed Shop. So annoying stuff like this we can handle via this escaping mechanism. So if it's a software-specific EasyBlock, you have to follow these rules, and you can ask EasyBuild how to encode the class name like this. So there's a function encode class name. You can just give it the name of the software. In this case, it's netcdf-fortran, and it will tell you the right class name to use in your EasyBlock. So this is what it will be looking for netcdf-fortran. For TensorFlow, it's easy. We'll just do eb underscore TensorFlow. There's nothing special. So for software-specific EasyBlocks, you have to follow these rules. For generic EasyBlocks, you can do anything. So you just name the EasyBlock freely, typically without an eb underscore prefix, because there's no escaping there. You have full freedom of how you name the EasyBlock. So configure make is just the name we came up with. We're not really tied to the software there. So the class name is one aspect. The module name and also location. So the actual Python module file has to have the right name as well, because EasyBuild will also look for it by name. There, well, the EB underscore prefix, you don't use it for the module name. That's only for the class name, because there you have other limitations, like you can't use a dash in a Python class name, for example. Basically here you do everything lower score. If you have any dashes, you make them underscores instead. So again, you can just ask the EasyBuild framework what the name should be. So there's a function for it, just call it and use that. TensorFlow, no problem, it will just be tensorflow.py, all in lowercase. Alright, so let's get started with that. Let me pull up an editor and make it big enough for you to see. So I'm just gonna, in my easyblocks copy, I'm gonna do tensorflow.py, start it here. This is not where it's strictly supposed to be. It should be in EasyBuild, EasyBlocks T, and then TensorFlow. But for now, I'm not gonna care where it is. It could be anywhere really. This is not gonna block me from actually testing it. So we have a TensorFlow.py Python module. I will add a class EB TensorFlow, so following the rules that EasyBuild prescribes. This is going to be our base. We're doing object-oriented programming here in Python, so we'll need to derive from the abstract EasyBlock class, or maybe something else. We can maybe change this later, it depends. That also means we have to do the import from framework of the EasyBlock class. So this is going to be our base install step. If you don't fill in those gaps, it will just not work. I can probably already show you that. So let me get a readable terminal here too. White background and black font. A bit bigger. So I put the TensorFlow EasyBlock here. If I want to test this, I also need an easyconfig file. So what I'm going to do, I'm going to copy the one that we have and I'm going to start mucking with it. So we have one here, Python 3. Let's rename it. And also open this one. So here I'm still using the Python package EasyBlocks. I wanna get rid of that. I'm writing a software specific EasyBlock, so I'm just gonna get rid of this line. So EasyBuild is gonna pick the TensorFlow package based on this name, and I'm using lowercase f here, so I have to do this here too. So it has to be the same thing. I'll have to add Bazel as a dependency here for all of this to work, but for now this is going to be good enough so I can test the EasyBlock. So let's see what this is going to give me. What I want to do, so the EasyBlock is not in the right namespace yet. EasyBuild won't find it as is. There's a useful option, include EasyBlocks, if you're playing around with EasyBlocks, implementing new ones or customizing existing ones, you can get them included like this. So if you specify the path to the new EasyBlock or the changed EasyBlock via include EasyBlocks, EasyBuild will basically copy it to a temporary location, set up the namespace right so it can import it. So you don't have to worry about that anymore. The other option I'm going to use is extended dry run, which is basically going to show me what it's going to do without actually doing it. So this will be following the EasyBlock implementation without actually doing anything. So it's going to give me output in just a couple of seconds. So I'm going to pipe this to less here so I can scroll through it. So this is going to tell me dry run using the EB TensorFlow EasyBlock. So I got that right. Based on the software name, it's picking up the right EasyBlock. If I wouldn't do the include, it would tell me it can't find the right EasyBlock. It knows it has to be software specific because there's no EasyBlock equals line. And here it's still telling me about the fallback to configure May that used to be there. So it's assuming there's no EasyBlock line in there. I can't find a matching software specific EasyBlock. So maybe you forgot the EasyBlock line. Actually, in this case, we forgot to do the include. So it gives us an error that's kind of helpful, I hope. So it's picking things up. This messy bit here is just a temporary location because we included it via include EasyBlocks. Usually this is just a part of the EasyBuild installation you are using. So you can see it's already showing us how it's going to do things. There's a fetch step method implemented in EasyBlocks, which we're not going to change here. So this is going to download the sources. Of course, this wheel will have to change that too, but that's not a big concern for now. Because we're going to focus on the implementation of the EasyBlock without actually doing the build itself. It will go through each of the steps and it's going to give us some useful information where relevant. And here we already have one issue. So the extract step method doesn't know how to unpack wheels. So it's not like a tarball or something. Yeah. Well, you can check the documentation. Basically, everything I'm covering here is in the documentation. So if you go to the EasyBuild documentation, there's a link on the left here, implementing EasyBlocks. That's basically what I'm stepping through. So basically what I'm doing now is I'm showing how I'm going to test the EasyBlock, and I'm going to come back and step through most of this. So extract step, this is something I'll have to change. So I guess the sources these are all wheels on PyPy, so which is not what I want. I want to get the actual sources, and I guess this thing is going to tell me where they are. On the top. Here, okay, yeah. I probably have the latest release here. I'm not going to use the RC. I'm going to use the, what is it, .12 release. Alpha RC. Ugh. Okay, this one. So I'm going to use this tarball basically. I'll change this in the easy config file. So rather than, I have it open here. Rather than using the wheel, I'll get rid of this. Get rid of this. So I'll just download the tarball straight from GitHub to get the raw sources. Like this, and here it's, I'll just hardcode the version for now. This checksum is going to be wrong, so I'll get rid of it. And of course here I'll need build dependencies, Basel, and it's 04 something. Not yet, so I'll comment it. Well, actually, extended dry run isn't going to care that the module isn't there. Yeah, but I know the latest one is 0.41 or something. So I'm not going to do the Basel easy config file for now. Extended dry run is going to tell me it's not there, but that's fine. But now we got rid of the errors in extract step. So EasyBuild knows how to unpack a tar file, and it's telling us I'm gonna unpack this with this command, and which means you'll probably have a build directory that looks something like this. So it's making guesses here because it never actually downloads a tarball, but it's gonna give us all useful information. The next problem that we're gonna have, so other than not actually having the modules that we need for the toolchain or the dependencies here, so it simulates these loads in the dry run. I'm gonna ignore this F50W error. This is only for the the Intel toolchain, just because I don't have it here. It's also going to give us the build environment, but I'm going to skip this for now because this is the next problem we have. So a little bit confusing because it's not actually showing the error, but this is because the configure step is not implemented in the easy block that we're deriving from. So this abstract easy block doesn't define any configure step at all. It just does not implement it. So we'll always get this error. So the next step is to actually try and implement the configure step like this. So we start defining the method which is going to override the not implemented definition of the abstract easy block of this one. So this is where we will call out to the configure script that TensorFlow provides. If we look back at the documentation, so this thing is what we're going to call out to, and it looks like it's going to be a Q&A script. So it's going to be an interactive script. So what we'll do is we'll do run command QA ./configure and then some other stuff around it. So the assumption you can make here if you're running the configure step is that you're already in the unpacked build directory. EasyBuild will just set that up for you, giving the tarball, it will cd into the directory so everything is set to go and configure. Of course we have to do the import for run command QA, which is in tools.run. And let me make a mistake here just to show you how it pops up in the extended dry run. So it should pop up pretty quickly. So it's going to tell us, yeah, I can't import this, you made a mistake. So you go ahead and fix it. Do the dry run again. If we now go on to configure step, it's probably going to be another issue. Yeah, we just gave it the command to run. Run command QA needs an extra argument and needs a mapping between questions and answers. So it'll have an extra argument here. I'll just call it QA, which is a Python dictionary. So of course, when implementing EasyBlocks, you need to be a little bit familiar with Python, with the data structures it has. So this is going to be a dictionary, a mapping from strings to other strings in this case. So what I'll be doing here is telling EasyBuild what the questions may be and what the answers may be. So I'll just do a couple of them, I won't do all. So specify the location of Python, and default is user bin Python. So I'm gonna assume this is literally the question I'm gonna get, and the answer is gonna be the Python that will be used as a dependency in EasyBuild, rather than the system Python in this case. So what I want to do here is I'll call this Python root. So here I'll just use the function to get the installation prefix for Python. Yeah. I mean just a list of answers to... No. It will assume that things are in the right order, but you may be giving answers to... If they inject a question in between, it's just going to fall on his ass. Should you pass the mic? Or?
I'm not sure question answers. I mean, it's fine to go through it to show it, but
I won't go through the whole thing.
If I looked at the configure script, they're just...
Maybe I'm just following the documentation that it's showing me, right?
But I'm ignoring their documentation, reading their code, and they'll allow you to override with environment variables. Like they have a bunch of... These are all just filling in environment variables. Like if you look at the configure script, it'll ask that only if the environment variable isn't set.
Okay, but then you have to dive into the actual script and see that.
Code is documentation.
Why? Yeah. Sometimes there's like a silent option as well, that you don't have to do interactive, but EasyBuild can do the interactive. It works.
I have a question here, and that is what if the default Python for whatever system is user been Python 3? Then your pre-specified question
You
would not
think,
actually.
well, this could be either hard coded, or they could guess it based on the available Python. That's true. That's a good question. So here I'm
Maybe
just
should have a.
assuming that this part is hard coded, which what they actually may be doing is doing a which Python and using that path.
Yeah.
Yeah. Okay. So yeah, it's a good question. So here it's a hard match, but you also get an option, and I actually have to look it up myself. Um, so now I'll have to dive into the EasyBuild API documentation, which is here at the bottom. I'll go to tools.run here, and here run command QA. So this is all the options, arguments you can give it. These two have to be there. So the command to run and a strict mapping of answer to question. It also has this standard QA optional argument, and here we can give it patterns. So if you're concerned about this, what you could do is it needs a dictionary for QA. You could do a standard QA12 like this, and here you can use regular expressions. So you say default whatever, and then of course you have to pass it down here. So it does that too. The difference is that this one it doesn't take any regular expressions. It has to be a hard string. It does hard string matching. So for standard QA, it's called standard QA because you may have the same question a couple of times and you just want to give the same answer. Like, do you want to do this? Yes or no? Yes, 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 yes. Just keep saying yes. Accept, yes, yes, yes. Keep going. So that's typically what you use it for. You can also use it for these one-off questions where a part of the question isn't clear, and you can actually take it a lot further. What you also can do is so this is just regular, what's it, like this, P. So this is a match with giving a name to the match, and you can refer to that name again here. Something like, no. I forget how you do the reference, but you can basically take a part of the question and then shove it into the answer. This is something we do for Wharf. It gives us the question like, which compiler do you want to choose? And it gives us a list with numbers, and the numbers change between releases. So you don't want to hard code the number. You want to do a pattern matching like Intel version 15, this number, and use that as an answer. So it can do very cool stuff. Here we don't really need it. We don't need this part of the question. We know which Python it's going to use. So the QA stuff is pretty advanced. So basically here you would have to flesh out all the questions and answers that the configure script would give you. I'm just going to assume for now this is good enough. So let's say this allows us to run the whole configure script to completion. So let's see how this looks in the dry run. I'm just going to look for configure step. And now it says I'm going to run this interactive command. And it's not giving me all the details about the Q&A. It just assumes that everything will be fine. It just tells you it's going to be interactive. Next step is the build step. Same problem. It's not implemented yet. We'll have to tell it what to do. So how do you need to build? So you need to do Basel build, optimize. And then this is, what the hell is this? The build directory. Okay. That's like a relative, yeah. And this is what this is the actual build command, right? Yeah. So what we'll have to do is we are in the build directory, so I assume we'll have to pass this as the subdirectory to find stuff. So I don't have an unpacked TensorFlow here. I'm just guessing. I should probably just download it and unpack it so we can actually see what I'm dealing with. Yeah. So let me. So it seems like this is the directory there. Well, tools. Okay, yeah. So it seems like I can just copy paste this command. There's nothing I really need to specialize here. This is the literal command that we want to use for the build. So that's what we'll do. We'll define the build step method in a similar way, and here we'll run this command as the build step. This is a non-QA run command, so we'll have to do this import as well. Check the driver again to make sure we didn't do anything stupid. So build step, okay, I'm gonna run this command. Install step, same problem. I think the installation is just copying out. Oh no, it's doing a pip install. Okay. So this is sudo here. Of course, we're not going to use sudo. And then what's this thing? Basel bin. So this is the subject that gets generated, I guess. Yeah. So I'll have to literally run this command. The temp directory, I probably want to do something else here. So let's see what that will look like. And this is still part. This is probably still part of the build step. So we're actually going to have to run 2 commands. Which is fine. We'll do this. So this part is probably fixed. So this is just a directory with a binary in it that was generated by this command. That's what it looks like. Here we need a temporary directory. We're not going to do hardcode temp TensorFlow package. We're actually going to use a directory that EasyBuild has prepared for us. In this case, we can use probably the build directory that we're in. So basically the unpacked TensorFlow tarball. I'm just going to dump it in there because this is going to be cleaned up anyway afterwards. So this should be okay. And then for the install step, we'll need to do pip install of the wheel that is generated in there. Okay. It has a Python version here and there's none any, but there's only going to be one wheel there, so we can do just a regular expression, a glob pattern to grab the part of the wheel. We'll have to do pip install without sudo. We'll do a pip install prefix. So again, install step, run command, pip install. So the directory we specified and then the wheel in there. So that's gonna go here, which is gonna be something like, so I'll do wheel location. So that's in Python you would do this with a glob, which is like in Bash doing letting Bash expand the path. It's pretty similar to that. So it's gonna be in the build directory and it's gonna be star.wheel. The glob is going to give us a list of paths that match. We expect only one, so we'll just grab the first entry here, which should be okay. Of course, we're gonna have to test all of this, and we just inject this in the pip install. Now we're not using a prefix here, so that's not going to work. We're not using sudo, of course. I want to try and avoid doing the pip install entirely, like directly here, because EasyBuild knows how to do pip install in Python package. So it seems like we're implementing this whole thing straight from EasyBlock. We may start to reconsider this and actually derive from Python package instead. So let me take a look at Python package. The configure and the build step are clearly very specific to TensorFlow, so I'll leave those in. And let's see what the install step does here. So this thing knows how to set up the Python path so it can install things. It composes an install command based on some magic. It knows how to do pip. It has a use pip option that we could set to true. So it's using that here. So this is basically what it's doing if use pip is set to true. So it's going to use the pip install command. So what I think would work is rather than install step, where is it getting the file to install from? Now I have to figure out my own code again a little bit. This is a bit of a mess. Well, it's not a huge mess, but so usually it does install command and it just gives a directory, which is not going to work because we're getting a wheel file and we really have to install the wheel file. So probably the easiest thing is to stick to the pip install, and we can sneak here how it does a prefix, pip install prefix. This is where we are using the wheel file, and we could allow it to inject install options as well. So I'll do this. We'll inject the wheel location and the self install there like this. So it's going to be very specific to TensorFlow. Of course, we'll have to test this and iterate over it because this is not going to work straight away. But it gives you an idea of how to map the documentation to an actual EasyBlock implementation. Now let me go back to the documentation I wrote because I certainly skipped a couple of things. So the high level structure of an EasyBlock is exactly what I showed. You have a class, you have a couple of imports of functions that you can call from the class. For example, running commands is one example. In this case, we derived directly from the abstract EasyBlock class, but you can also derive from an existing generic EasyBlock. And I have an example of that here as well in this section. So rather than deriving from EasyBlock, which forces us to implement, configure, build, and install, we can actually derive from an existing EasyBlock, for example, configure make, and just do something extra, either before or after the configure step of configure make itself. So what we're doing here is we're copying an example file to an actual file that we're going to use, and then we call out to the parent, so we do configure make dot configure step basically. So this is useful if you have things that you have to do something specific on top of the generic installation procedure. For TensorFlow, that doesn't seem to be a very good option. We have to do lots of custom stuff. So right now, Basel, I only know about TensorFlow using Basel. There may be other packages as well. And if you have 2 or 3 of them, maybe you can reconsider creating a generic EasyBlock for using Basel and then letting the others derive from that. But for now, that doesn't seem to be something we have to dive into straight away. Some more specific aspects. In an EasyBlock, you can define extra EasyConfig parameters that are picked up by the EasyBlock that you can use. So here, for example, we have one extra parameter that you always have to specify. So it's a mandatory parameter. You can add custom parameters as well. And then you can take the values that were set or figure out if they were set or not in the EasyBlock. This is being used in a couple of places. The EasyBlock constructor, we didn't need it here, but if you want to have variables that you can refer to in different steps, so in different methods, you need to make a class variable like this, so you can refer to it in different places. So maybe you can set a proper value, so something not none, in the configure step, and then reuse it later in install step. If you want to do something like this, you'll have to use class variables. Otherwise, you're using local variables that are only specific to the method. Access to files, reading files, writing new files, maybe appending to an existing file, copying files around, and even patching files, or like runtime patching during the build. That's something that functions are readily provided for. I didn't give a full out example here, but you could look into the EasyBlocks repository. So if there's a function that you think may be useful, you can just search here. You will straight away get some hits. So here it's doing something, search and replace on config flags, and injecting an extra configure option into the make file. So runtime patching, sometimes you have to resort to that. Executing shell commands, this was covered. So run command QA, they just basically take the command, and if it's a QA, it also takes a dict. You get some extra options. You can, by default, EasyBuild will check the exit code of all the commands it executes, and it will also return the output as a return value of the function. So maybe you want to check the output, do some like grabbing, searching in it to look for success or something like that. Check the exit code, which is already done by EasyBuild. You can take control over that yourself using simple true, using simple true or simple false, depending on what it does by default. More options for the QA, like the regex pattern matching on the questions. If you need to set environment variables or update environment variables to be picked up by the commands that you execute, you should use the setvar function we have. You can also do the standard Python thing of OS environ, but then it won't show up in the extended dry run output. So you won't see that EasyBuild is setting environment variables. So it's better to use setvar.
Question on that one, because for the EasyBlock, I'm thinking of for the system MPI. I want to grab environment variables and insert them into the module file. So, will that allow me to do that too, or will I have to do that separately?
I don't think. Do we have a getvar? We may have. Let's look into the API. I don't know by heart. I think for getting stuff, it doesn't really matter. You can read the full environment, but
that's probably enough though, because then if I can read the full thing, then I can grab out the stuff.
Yeah,
I know, for example, every open MPI variable starts with OMPI, right? So I can just parse the list. That's perfect.
Yeah, so there's a whole bunch of things. Yeah, read environment is I don't know why it's actually there, because it doesn't give you any added benefit of just using OS environ. It's just for consistency, I guess. They have something to get and set. Log statements. So we didn't add any log statements in our TensorFlow EasyBlock, but it's actually a good idea to do it. So log statements are just something like informative messages that tell you where it is in the build. Now EasyBuild already logs a lot of stuff. It's going to tell you which step it's going to start to run. It's going to tell you which commands are running, what the output was, what the exit code was. That's all going to be in the log already for you. But you could add some stuff here that you can easily grab for, like starting annoying interactive configure, just stuff like this. You can do log info, log debug, and depending on how verbose you make the log, you will see the information or not. Of course, here it's silly, but sometimes you wanna like maybe here you want to show the contents of this directory or this list of wheel files, just in case there are multiple ones that are being generated, so you can actually tell in the log what was there. Because once the installation is over, the build directory is cleaned up and you don't have this information anymore. So maybe you want to dump it in the log file. The sanity check. Usually when you implement an EasyBlock, a software-specific EasyBlock, you also include a proper sanity check in the EasyBlock. This is actually kind of a fallback sanity check because you can still specify a separate sanity check in the easyconfig file, and that one will win. So if we go back to TensorFlow, there's a sanity check in here, which was for the wheel, and we expect to find the same stuff when using the EasyBlock, so we could implement it here as well. Sanity check step. It needs a dictionary with paths, so for both files and directories, and then we call out to the parent, which you do like this. We pass the paths here, and here we want to look for bin tensor, what was it, board, and a directory lib python, the version, and then side packages. There's going to be lib python, inject the version here. Is that it? Yeah. And here you would like get software version Python. You would have to cut off the last digit here, but you get the idea. So this will look for a file, bin tensor board, and a non-empty directory this, just like it would here, which means you can clean this stuff up. There's more that you would have to clean up, like use pip is useless because we're calling pip directly. Unpack sources, we actually want to unpack the sources because we're not building from a wheel directly anymore now. So it cleans up the easyconfig file a little bit. This we don't need anymore. This was for the wheel. We can just hardcode the Python version in here to 7. Well, it was 3.5 actually. 3.5.2, so just like this. So we can clean up the easyconfig file quite a bit and basically dim it down to only having to update the version of TensorFlow itself, of the dependencies and the toolchain, and we wouldn't change anything else anymore here. So that simplifies it. So hopefully this is a one-time only effort to implement an EasyBlock for TensorFlow, as long as they don't change the build procedure, which has actually been happening in the recent versions. This would keep working. So TensorFlow is close to 1.0, I think. So we would hope that also means the build procedure is stable. So the Basel package they are using is still in beta in Google, but yeah, I mean, I think even Gmail is still in beta, so it doesn't mean anything. What else? So the custom sanity check, it's good to add here. You can always escape it if you really have to in the easyconfig file. Sometimes you have version specific things. So maybe in the sanity check they renamed some binary file depending on the version. So you could add checks like this to, depending on the actual version being being built or installed, you can make some exceptions here, which again avoids you to copy paste things around in easyconfig files and make sure that things match with the version you're actually installing. So again, it's do once and forget. It does mean that you may have to revisit the EasyBlock later for new versions of the software and update it, but that's something you can't really avoid. As I've been showing, I should actually do the extended dry run again, because by now it should be reasonably happy. Okay, I forgot an import. So as you can see, it's pretty useful to have the extended dry run because it gives me feedback in seconds. Another import. list index out of range. Yeah, this is actually a good example. So what I was assuming here is that this glob is actually going to give us a hit, at least one hit. So this glob will give us a non-empty list. Now the code is actually being executed during the dry run, but the build directory is totally empty, and these run commands were not actually run because there's nothing there. So this means that this glob is actually not giving us anything at all. So to make it dry run safe, the easy block, we would have to change it a little bit. We'd have to do something like this. So we get the list of locations from the wheel. If we get one or more locations, or if we get, let's say, exactly one location, then we know what to do. Then we just grab the first one and do pip install. If not, and only, yeah, if not, we could fail. And fail is something like this: race EasyBuild error, no wheels found in. So this is an aspect I don't think is covered in the documentation yet, throwing errors. I should add that too. So this would give us a useful error. This would still give an error in dry run mode, but we can actually check if we're in dry run mode. So if we're not in dry run mode, then we're just gonna basically ignore that we're not finding so then we're not going to throw an error. The downside is we will also not see that it's doing pip install. So that's maybe not what we want. So rather than doing this, we could do, if we're not getting exactly one and we're doing extended dry run, then we just give it a dummy path and just continue anyway. Something like this, and a little bit more specific. Only if we do dry run we do this, and else we error out. Is that clear what this changes? So we grab the list of wheels, we expect to find one if we're actually doing the build. If we don't find one, then if we're doing dry run, we say, okay, it's normal during dry run that we don't find anything, we inject a dummy value. So basically this is happy and doesn't crash on us. Maybe better name. And if we are not doing dry run and we didn't find exactly one match, then something is very wrong. Now, could also be more than one. And it's probably good to give us like this list to show whether it was empty or whether there was more than one. So the error can be more useful. But this should help fix this warning. If I got things right. Another missing import. So now it seems to be happy in the install step. No, a typo. See, it's actually executing the code and checking on me. That's good. Because it may take some time for it to do the configure, maybe 5 minutes, and if you then run into a typo, it's very annoying. The driver will give it straight away, because it's basically skipping all the commands. So this looks better. I'm not getting any useful messages here in dry run mode for installation, which is strange. Why am I not seeing the command? Oh no, it's here. Okay. Yeah, so this is the start of the installation step, which has a couple of methods. And now it's actually showing me the pip install command that will be run. And I can't scroll back. Why can't I go in? Yeah, anyway, it'll show me the fake dummy wheel in this case because that's what we injected. Another missing import here in the sanity check, but you get the idea. And basically what you want to aim for ideally is that you're not getting this error or warning. So if you don't get any ignored errors, it's very likely that your EasyBlock is okay. There's nothing, no typos, no missing imports. It can run through the commands and the logic makes sense. So that should be your first goal before actually testing the full build. Of course, you can do the build manually on the side to figure out in which situation you're going to end up with and where you need to go. But that's kind of how I usually do the implementation. So for compatibility with extended dry run, you may have to check if you're in extended dry run mode and do something a little bit separate, like just faking that a directory is there or faking that you actually read a file, because contents of files you wouldn't be able to get either. Same thing for module only, and module only you have to be careful in the make module and the sanity check step. So module only means that you're basically skipping configure, build, install steps. So all of that logic is not executed. And if you're then also setting variables there that you refer to in the sanity check, your EasyBlock may crash under module only while it works if you do the whole installation. So that's also something to take into account. And that's something Jillian reported a while ago, I think, that in some cases make module crashes pretty hard with some EasyBlocks. Was it you? I think, yeah. So here it helps you a little bit to see what you have to keep in mind. Include EasyBlocks I already covered. So usually it gets picked up and it has to be. You can check on yourself if you do include EasyBlocks with list EasyBlocks. If you see your EasyBlock listed, it means it got picked up correctly. If you do detailed, it will also show the locations of the EasyBlocks it's picking up. So even if you're giving it an EasyBlock that is already included in EasyBuild, you can check that yours is actually winning over the one included in EasyBuild. Testing EasyBlocks, so what I did here with extended dry run is a good way because it gives you a quick feedback loop. And once you get that pretty happy and it looks okay from what it prints you can actually go in and do the full test and see whether the documentation is up to date of the build procedure. Or if you run into some nasty surprises with compiler errors or who knows what may happen. You can get an early look at how the module would look like as well with module only force. But I think this requires that having all the dependencies are installed. So I can't do it here because I don't have Basel and stuff. But that's another way. If you want to get an early preview of how the module file would look like, you could do this with module only force. And it would show you up to a certain level what is going to be there. This is work in progress here because I was kind of planning to do this live coding, and I hope to flesh this out in more detail based on what I did here. Basically, I want to keep this rather short, which may be possible, and actually put a fully working TensorFlow EasyBlock here. We already have it for Wharf in the wiki, but it's a little bit outdated. So in the older documentation, this is the old version of basically this documentation, which covers a lot of the same stuff. The nice thing here, and I would have to double check if it still works, but you could actually copy paste the code snippets here, put it together, and you would have a working EasyBlock for Wharf that you can play around with. So the one I have now for TensorFlow is probably not going to work, but this one worked. And it's a dimmed down version of the real EasyBlock. It only covers certain compilers and so on. Let's see, I think I covered everything I had in mind. I'm going a bit over time, but maybe we have time for one or two more questions. Did this help with getting an idea of how EasyBlocks work and what you can do and how you should approach things? Yeah? Okay. Any questions? Yeah, Guillermo.
generates no, it actually uses files with hard-coded paths. So we cannot use their environment variables. And then, how would you do on a EasyBlock to fix hard-coded paths on files that are used by this Bazel?
You mean like text files or?
Text files that they have the include files for GCC that are hard-coded, also paths for NVCC hard-coded. So how would you? We did a SAD, for example, but
Yeah,
on
well,
the shell part. But how do you do that in the EasyBlock?
you would use this function. This is for runtime patching of files in the EasyBlock. And there's some examples here. I think we do it here for Metis. So here we basically tell it we inject this extra CMake flag into the make file. So we look for the line that says config flags equals something. We take everything that's there and we add an extra. So you can do search and replace with this regex. You have to do Python regexes though. So, but with set you have to do it anyway. So it's close to that. This would be the Pythonic way. The nice thing is if you do this, if you use this function and you do a dry run, it will also show you what replacement is going to do, so you can check whether the regex is compiled, for example. So yeah, this is fairly recent. There is the way you usually see this in Python. They use the file input module, but it's weird to use it. You have to open the file with file input and then just write to standard out, but it's actually going to the file. It's a little bit weird to work with. This basically wraps around it. Gives you a cleaner interface. It's the equivalent of set. Yeah. More questions? No? Okay. Yeah.
In your example, configure has the different signature than these ones. So when should we use QArgs and args like you're showing there?
A different signature?
Yeah, you have self.
Here,
args, and
okay.
QArgs.
Yeah, here this is useless. I mean, you can see something like this pop up in generic EasyBlocks that you may derive from. So if you pass extra arguments through, that they also are being used here. But args and KW args are not being used in this block at all, so you might as well just drop them. So this is the Python way of getting extra arguments and getting extra named arguments, so optional arguments in. And you can then pass them down if you have to. They're not being passed down here, so you can just wipe these. Here it's important. So in the constructor, you have to do this, and then also pass them through to the actual constructor. So sometimes it matters, yeah. It's not overriding one. It's adding. Yeah, but this is a software-specific EasyBlock, so there's nothing that the. Yeah. Yeah, I don't know why it's there. We weren't paying attention. And it's okay if it's there. It doesn't do anything.